All right, we're in section 10.3 where we're going to define and use probability. So, in this section, we are actually going to look at two different types of probability. All right, the first one is we're going to look at theoretical probability. Theoretical probability there, by definition, says when all outcomes are likely to occur, that an event A it's going to be represented by um, essentially the number of possible outcomes or number of favorable outcomes divided by the total number of outcomes. Next, we'll talk about experimental probability, and that deals with what actually happened during the experiment. So then that is defined as, or at least the equation for it will be like number of successes divided by the number of trials. So, for the first part, we're going to look at uh, theoretical probability, and then we're going to get into experimental probability. So for this first question here, it says a standard deck of 52 playing cards has 4 suits with 13 cards in each suit. So they want you to find the probability that you are going to draw a spade. So in this case here, there are 13 cards that have a spade. So there are 13 successful um, favorable events. So the 13 favorable events to you to draw from, and it's going to be divided by the total number of cards. In this case, there are 52 of them. Reduce that, it turns to 1/4. Or if you attach it as a percentage, 1/4 as a percentage is 25%. Okay. Next, they want you to find the probability of drawing a red queen. Okay, so playing cards are broken up into two colors, black and red. So uh, they have, I believe it's the diamond and the heart are made up as red. So you have two favorable outcomes in this case divided by 52, which then equals 1 over 26, or if we attach it as a percentage, is about 3.8%. Okay. All right. So different question here. It says there are 24 students in your gym class. The teacher divides the class into two equal baseball teams. Your team randomly draws one by one to determine the batting order. What is the probability that the students will bat in order of height, shortest to tallest? Okay. So here's the thing. So when we look at batting order, so there's 12 players on the team, so you're going to make a list 1 through 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So each one of them is going to be placed in a spot. They want to know uh, what the probability is if, the first batter is the shortest person on the team, all the way up to batter number 12, who's the tallest player. So this is a permutation. So we have on the top in the numerator, when it comes to the fraction, we have one favorable outcome. All right, we have one favorable outcome where everybody is listed in order from shortest to tallest. In the denominator, we have to figure out what the total possible outcomes there are. In this case, since there are 12 um, objects, 12 players. We can position them in 12 different batting orders. It's going to be 12 factorial as our denominator. So if we were to figure out what that is, 12 factorial is just essentially 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12, which is going to be 1 over, it's gonna be what, 4, 7, 9, 0, 0, 1, 6, 0, 0. So we got here in here. So there are 479,001,600 possible outcomes. So if you were to attach that by a percentage, it would essentially be, well, let's just put it as a decimal. It would be 0 point, and then there would be what? Eight zeros, one, two, three, four, five, six, seven, eight, and then the number two. All right. So very small probability that that is going to occur. Next, it says, what is the probability that two of the five females on the baseball team bat first? So probability of the first two batters are female. So um, it doesn't matter which females bat first, they just want them to be female. So in this case, this is a combination. So in the numerator, the favorable outcomes are going to be the five females, so that's going to be my value of n. And then my value uh, here is going to be 2 because I want it to be the first two. And then we're going to divide it by, and now we're going to look at the combination of all of the batters being in there, whether they're male or female. This is going to be 12, and we're going to look at 2. So looking at using, remember, the combination formula for n and r, n factorial divided by n minus r factorial times it by r factorial. When you plug that 5c2 into the formula, we get there are 10 favorable outcomes. And when we do 12c2, we get 66 favorable outcomes. Uh, 10 divided by 66, that gets reduced to 5 over 33, or about 15.2%. Okay. The last one on this page, it says find the probability that four of the seven male players on the baseball team bat first in any order. Okay, so again, in any order, this is again another combination. So the favorable outcomes would now be there are seven males, and we want to see if they bat in the first four. And then the total possible outcomes is all the players in there, so it's going to be 12 and 4. Okay, so 7C4 is going to be 35 favorable outcomes divided by 12C4. That's going to be 495 favorable outcomes. So 35 divided by 495. If I reduce that, that's going to be 7 over 99, or about, looks like 7.1%. Some facts about probability, especially both theoretical and experimental. Uh, Values range from 0 to 1. So it could be from 0% to 100%. You know, basically that's what they're trying to determine. 0 to 1 is meant as a decimal. 0% probability means that the event won't occur. 100% means that the event will occur, will always occur. Probability values are expressed as fractions for sure, in lowest terms, or in decimals, usually to 3 decimal places, and as percentages to 1 decimal place. Okay, so keep that in mind when we're looking at things that deal with probabilities. So we have a couple questions they have here. We are looking at the likelihood of choosing an integer between 1 and 50. So here it says they want you to find the probability of finding an even number, and then the next thing is they want you to find the probability of finding a perfect square. So even numbers, they kind of gave it to you here, 2, 4, 6, 8, all the way up to 50. If you count it out, there are 25 favorable outcomes divided by 50 total outcomes. And then this gets reduced to 1/2, or 50%. So you have a 50% chance of getting an even number. In the second question, they want you to uh, find a perfect square. So they've gotten some of them here. So 1, 4, 9, 16, 25, and 36. So 1, 2, 3, 4, 5, 6, 7. There are 7 favorable outcomes divided by the 50 total outcomes that could possibly happen. And that is lowest terms, and it is about 14% as as the likelihood. If we look at the bottom here, um, now they want four, multiples of four. So in this case, they gave you some of them 4, 8, 12. So we got 16, we got 20, we got 24, 28, 32, 36, 40, and 44, and you got the 48. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 favorable outcomes divided by 50 total. That fraction gets reduced to 6 over 25, or about 20, is it 24%? All right, the last question on this page is so it has two-digit numbers. So it starts with 10, ends with 50. So if you go here, 10 to, actually, let's do it this way. So you got 10, we'll leave by itself, and then we're going to go 11 to 20. Then we got 21 to 30, 31 to 40, and then we got 41 to 50. So here's 10, here's 10, here's 10, here's 10. This is 1. So we have 41 favorable outcomes over 50 total. All right, 41 over 50 is in lowest terms, and if attaching that as a percentage, 82%. All right, another thing that we're going to look at is odds. Odds are different um, than probability. Odds are broken up into two different categories. You have odds in favor and you have odds against. Anytime you're looking at stuff that are odds in favor, you are looking at the favorable outcomes divided by the unfavorable outcomes. Odds against is just flipped. Unfavorable outcomes are on the top and favorable outcomes are on the bottom. So, looking at these questions here, it says a marble is drawn from a bag containing 6 red, 12 yellow, and 9 black marbles. They want us to first, the number of red marbles, well, they're saying that is 6, and then they're looking for the number of marbles that are not red. Well, that is going to be 12 plus 9, which is 21. Okay, here, because it said odds in favor, we have favorable outcomes on the top, which is 6, divided by unfavorable outcomes, which is 21, and that gets reduced to 2 over 7. Okay, now they don't put percentages on odds because it doesn't deal with probability, so we just leave it as the lowest term fraction. Uh, B is find the odds against drawing a black marble. Okay, so the number of marbles that are not black are 6 plus 12, which is 18, and the ones that are black are 9. So odds against means unfavorable outcomes, which is 18 over 9, which is going to be 2 over 1. All right, in this last one, it says a marble is drawn from a bag of 6 blue, 6 yellow, 9 white, 11 green. They want you to find the odds in favor of drawing a yellow. So number of yellow is 6. The numbers that are not yellow are 6 plus 9 plus 11, and that is 26. And so odds in favor are 6 over 25, which get reduced to 3 over 13. All right, so now finally we're going to talk about experimental probability of an event. All right, so it says when an experiment is performed that consists of a certain number of trials, the experiment probability is given. So you have the number of successes of whatever it's asking, what you're asking of it, divided by the number of trials in the particular experiment. So here we have, it says, exam grades of students in a history class are shown in a bar graph. Find the probability that a randomly chosen student in the history class received a C or better. So we have our chart here. Everything that was a C or better is here, here, or here. And one of the things that they're asking us to do first is list the total number of students who took the test. So we had what, 3 Fs, 1 D, we had 8 Cs, we had 12 Bs, and 7 As. That was a total of 31. All right, so on the survey, we had ones that received a C or better, which was 8 plus 12 plus 7. That meant it was 27. So we could say that the probability of this was 27 over 31, which is in lowest terms, or about 87% of the students received a C or better. Below here it says find the experimental probability that a randomly selected student received a C or lower. So we already know that the total number was still 31. And now we look at the values that were a C or lower, or at most a C. So it's going to be what, 3 plus 1 plus 8, and that is what, 12? So I can say that it's going to be 12 over 31, which is about 38.7%. And that is being able to define and use probability. Hope this helps. Till next time.